Good afternoon to everybody. My name is Kathy Moon. I am a professor in political science at Wellesley College and also the director of East Asian Studies. And today's event is being brought to you by, sponsored by the East Asian Studies program. And I'm very grateful to my East Asian Studies faculty, fellow faculty out there who are here to support us and also to participate. And I am very grateful to all of you for showing up. This is a big event, one of the first of its kind at Wellesley, and I'll explain in a little bit why that is. But let me just start right away and get our attention focused on Japan and all of the challenges that this country and society is facing and many others in that region, as well as potentially the United States. As you know, nuclear and radiation power, it doesn't sit still. And it moves, and it has been moving, and we'll get some expert analysis on that from my colleague, Professor Jim Besancon of the Geosciences department. And I want to start you off with this quote from an academic observer, a scholar of media studies, and he writes regarding Japanese television. Tokyo television coverage went from scenes of happy people pouring cups of healthy instant green tea to grim-faced newscasters estimating death tolls, from sleek, seductive ads for cars photographed under immaculate conditions to the flotsam of cars and jetsam of houses helplessly bobbing in a black tide. Glossy takes of starlets doing their makeup and comedians promoting luxury products were replaced in sequence by jumpy camera phone images of devastation and despair. And why this sudden change from the fancy, glamorous life of television to the flotsam, jetsam, and the shaky cameras? Well, we all know that it's due to the earthquake on March 11th. And the ensuing tsunami and the nuclear meltdown at some of the reactors. I start out with this quote about Tokyo TV, partly to emphasize or to remind us that most of what we know about what is going on in Japan comes from television or other forms of media. And since we cannot be there, I was actually supposed to be there for a conference during that time, and the trip got canceled. And I have to tell you, I was really scared. Part of me was hoping it would get canceled. The other part of me was hoping that I could actually be a witness, but I'm no Médecins Sans Frontières kind of gal, and I decided it's much safer if I stay home. So I was very relieved, and so was my family, when my trip got postponed. But at any rate, this is a very serious problem in Japan, but also with lots of lessons for us in many ways around the world. And rather than get into little tidbits of news through television or through the internet, what we want to do today is offer you a much more thoughtful exploration of some of the problems, issues, challenges, and human resilience that have come forth from the events of March 11th and afterwards. So our gathering today is to go beyond the 24/7 media cycle of headlines and have a more thoughtful, insightful analysis of this crisis. And in this endeavor, I am joined by incredibly energetic, visionary people from our Public Affairs Office, with Elizabeth Gildersleeve leading her team, together with Sandy Kendall and others in the Public Affairs Office. We also have the Library Technology Services with Kenny Freundlich, ever reliable, ever thoughtful, Nancy Germano and others, as well as Susan Challenger and the Alumni Association staff. Our event today is being live streamed, I guess across the world, you could say, and our alumni, many of them around the world, will be watching, will be tapping in, and some might even be tweeting in. This is my first time ever possibly encountering tweeters. I'm used to talkers, but not tweeters. So for those of you who are going to be joining us from far away, you can log on to Wellesley College's website into the public affairs page where the discussion is being streamed live. And you can also track Twitter. It says hashtag is TL Japan. Am I reading that correctly? TI Japan. I don't even know what a hashtag is, but I'll just convey that to you. And of course, those on Facebook can go into the Wellesley Facebook page and participate in that way as well. We will have time for Q&A, mostly from our audience. We will stop talking at 1 o'clock, and if we don't, somebody hold us to it, because this is really your day to ask questions and give comments. And we'll also be having a few tweeters possibly joining us and sending their questions in as well. So Jim Besancon, my stalwart colleague here, I'm so happy to do this together with him and writ large the Geosciences Department. I think a true liberal arts institution brings together all of its talents from a variety of disciplines. I've asked folks from the environmental sciences faculty, from East Asian studies, from political science, from the Science Center, from all over campus really to be here. And there are many here who are not always in the academic classroom, members of the staff and administration who are also here, so I'm very, very happy to see that kind of interest. But given that we are a liberal arts institution which takes our mission very seriously, we want to have this cross-fertilization of intellectual life. So I will provide a brief background of some of the political, social, economic issues, raise some questions, and then Professor Besancon will take over with the science aspect. He is an expert among many things, on soils, on geothermal issues. He leads projects both at home on campus, studying conditions here, as well as in the Blue Hill Mountains. And he's also an expert on nuclear reactors. And we are really lucky to have that combination in one person. When I read his bio, I said, this is it. I don't have to go any further. So I'm very happy that you are joining us. I also want to thank Cindy Northgraves, Administrative Assistant in the East Asian Studies Department, Esther Im, one of our very, very dedicated students who came up with the, who worked on, she and others worked on the flyers and also trying to get some of the circulation and advertising going on. And there are many others who have been part of this process.
Good morning, or afternoon. I thought this painting sort of said a lot. At one point, people felt that this was a storm wave, and then there was an opinion that maybe this was a picture of a tsunami. And I tend to the former just from the shape, but you can see with the boats and the mountain behind that giant waves are not unknown in Japan. What I want to talk about today is sort of three aspects of this disaster that all came together at once. So I'm going to first ask the question, why is Japan involved with this? And this is a map that geologists produce that shows what most of you know now about plate tectonics and how the outer shell of the Earth, essentially the eggshell of the Earth, if you model it as an egg, pieces are cracked and move around relative to one another, either together, apart, or past one another. In all of those interactions, we get earthquakes. So on a map like this, where you can see, and I'm just going to speak a little louder here so I'm away from the mic, that North America, with Alaska, and the U.S. up here, Florida, I can reach with my finger, is part of what we call the North American plate, one of these pieces. Interestingly, as you come across through Alaska into Siberia, you come actually, thank you, you come all the way down into Japan over on the left side as part of actually the North American plate. So we're closer together than you might think. The little red arrows here are showing the directions of jostling on these plate boundaries as they come together apart, either converge or diverge, or in a transform, slide past one another. In the U.S., our major earthquake zone is, of course, the San Andreas Fault there in California, which is where the Pacific plate meets the North American plate. But those same two plates are meeting offshore from Japan. And where there are plate boundaries, there are earthquakes. And people there are well aware because Smaller earthquakes are very common and are felt often in California and in Japan. They've been well known. The 1923 earthquake left about 4 buildings standing in Tokyo because of the fire that ensued. All the water supplies were broken, the pipes, underground pipes broke, and the fire took down almost everything in Tokyo at the time. So it's a long history of earthquakes, and terrible earthquakes, big earthquakes, in Japan particularly most susceptible to it, more than almost any other country. In detail, if you look at the left side, you can see the North American plate. The earthquake that occurred is just to the left of the arrows over there. And indeed, all of these other zones are places of major earthquakes. An earthquake essentially almost as large as this occurred in Alaska only a couple of years ago, but in a remote area. So really where an earthquake occurs is very important, because if it occurs under a building, as it did in Christchurch, it's going to bring that building down generally. Whereas a much larger earthquake farther away is less likely to cause damage. Here is a map of Asia, if you are familiar with major parts of Asia. I'm going to grab the mic again here. The Japan up here offshore is shown with a lot of red on it, which are high peak ground accelerations, which means the ground under the building is going to shake enough that it's likely to come loose from its foundation, and or pieces of a building are likely to detach and collapse or pancake downward, which is one of the major hazards in an earthquake. You can see over on this side the Himalayas being created as India slides north into Asia, and there's actually a zone that slides up across sort of Mongolia up there, which actually is a result of India and this whole plate here moving northward into Asia and actually essentially trying to break it apart as it cracks in there. And the Himalayas and the Alps are all part of that same zone of convergent plates. Other places, of course, well known, Indonesia, which had an earthquake in 2004, resultant tsunami, killed people all the way across the Indian Ocean, Sri Lanka, India, Bangladesh, much of Indonesia, as the waves spread across the Indian Ocean, which was perhaps a bigger wave and much less expected because we didn't really have the planning in the Indian Ocean that we do around the Pacific. In the Pacific, there's monitoring. There are modern countries on several sides that monitor and are able to tell you when an earthquake is likely to generate a tsunami and how to get out of the way if there is sufficient time. I have a sequence here of 3 slides from National Oceanographic and Atmospheric Administration. These are old. This is, I think, 1957 in Hawaii, and it gives you a small idea of what it's like looking down. And many of you have probably seen better pictures than this from Japan of what actually goes on when a tsunami is generated. The tsunami here is approximately, I don't know, it was 10 feet or so, and you can see houses, and the water, if you watch the sequence, simply comes in, and rather than washing back as a normal wind-driven wave would, so you see the wave come on and off with a period of 20 seconds or something like that. So you get continued waves coming on and then washing away. A tsunami is a little different because it just keeps coming. It's like a pancake of water headed onto the shore. And it comes on for periods from 15 minutes to 60 minutes in the very largest waves. So a tsunami wave is a wave that's going to come onto the shore, wash up across the shore, and keep going. And I think maybe the best picture of all of this is a picture of an airport in Japan during this event. And you can see in the very background is where the ocean is. And the airport buildings are here. Buildings are here. And what you're seeing in the dark gray area is the wave coming across. The shoreline is back there where the trees are in the dim, distant background. And the wave washes ashore and just keeps coming. Now you might think, oh, 3-foot, 5-foot wave, maybe you could stand in a 3-foot wave. Well, it's coming with houses and cars and pieces of buildings and anything else, trees, anything else that was in the way with it. So you don't really want to be in the water with one of these. The devastation is very, very radical. So what I want to say essentially is that earthquakes are survivable. Tsunamis also may be survivable. And I want to go over a few things that you personally can take away from this in case you're ever in an event like this. We don't know of anything for sure that covers the eastern coast of the United States. We know there are tsunamis generated in the Caribbean, so potentially areas south of here. We don't have any evidence of any coming onshore in New England. But as we travel, and we're all, most of us, world travelers, you may be in a place where something like this might happen. So when I go into a room like this, I always look up. Well, I don't always, but I usually look up because what the hazard is here is straight up above me. In an earthquake, the major hazard is something falling on you, like the ceiling, or a ceiling beam, or even a light fixture, or the glass in the windows, or an electrical wire. Are we exempt from earthquakes in New England? No. Magnitude 6 earthquakes occur here. Now, a 6 earthquake on the Richter scale is a significant event that causes a lot of damage. The last one in 1723 of that magnitude, off Cape Ann to the north of here, broke half the chimneys in New England by some accounts. That means widespread damage from a relatively modest earthquake. A magnitude 6 earthquake is significant. It's scary. When you go to a magnitude 7, it's 10 times the amplitude of shaking. If you go to magnitude 8, it's 100 times. And when you get to a magnitude 9 earthquake, which occurs only a few times in the century, perhaps 5 or 10, then you're looking at 1,000 times the shaking. A totally scary event, which if you survive, you will probably survive because it will be like 3 minutes, and either you have survived or you haven't. But what you need to do when the shaking starts is, if you're indoors, don't run out. Pieces of the building fall off the outside, and they fall in doorways, and that's actually a hazardous thing to do. So if indoors, get under a desk. So that table is my goal if the building starts to shake. And I'm sure Kathy will join me there. Yeah, right. I will share, yes. If outdoors, get away from trees, get away from buildings, get away from walls of any sort, and get away from power lines, which tend to fall. And they don't necessarily fall and stop having electricity in them. They may still be 10,000 volts coming through there. If you're in a high-rise building, get away from the windows. That glass is likely to fracture and come down. And it comes down in big pieces. Don't use elevators, needless to say. Get under a table. Stay away from outside walls. You might end up going out that outside wall. You don't want to do that. If you're driving, pull over to the side of the road and stop. Don't get onto an overpass. If you're on one, you should consider getting off before you pull over and stop. An overpass in California, in 2 earthquakes 20 years apart, fell both times. So that shows that reconstruction doesn't always do it for you. Stay inside your car until the shaking stops. Cars are pretty good protection. If in a crowded public place, don't run for the doors. You may end up causing more harm by pushing on people in the doorway than you would from having something fall, because it may not fall. Crouch, cover your head and neck with your hands and arms. If you're on the coast, and this is where Japan comes in, if you're on the coast and you feel an earthquake, go to high ground, because that felt earthquake may generate a tsunami, and if it does, you have very little time to get to high ground. Okay? So, main hazard, stuff falling on you. Most earthquakes are over in 1 minute. The longest ones are about 3 minutes. So it'll seem like forever, but wait it out. Then it's over, at least for a while. There may be aftershocks. There have been in Japan many earthquakes over magnitude 6 since this 9, including one, I think, over 7. So some large aftershocks. Now, the tsunami itself. Tsunamis have been called tidal waves, and that's a misnomer because they're not caused by tide, and they're really different than waves you're used to experiencing. They can be generated by earthquakes. They can also be generated by volcanoes. In the case of Krakatoa in Indonesia, a wave killed 35,000 people in fishing villages who were right on shoreline. The wave was as much as 40 feet high as it came down the coast. The thing that makes tsunamis so different is their wavelength. If you think about waves at the shore, you'll see a wave come in and wash out. Another one will come in. The waves will be maybe 100 feet apart or 50 feet apart or 20 feet apart, depending on the size of the waves. That's the wavelength from crest to crest. For a tsunami, that distance typically can be as little as 12 miles or as long as 500 miles. We have a very low wave out in the ocean, maybe a foot. Boats in the open ocean may not even notice when a tsunami passes. They may go up 6 inches. But as the wave comes on shore, a well-known phenomenon occurs. Friction against the bottom of the ocean begins to slow down the front of the wave. Now you can imagine standing in front of or putting a wall in front of a train coming at a wall, and the first vehicle, the engine stops, it hits the wall. All the other vehicles behind pile up, and the same thing happens with a tsunami. The front edge slows down as it gets to shallow water, and so what happens is the water piles up and it gets higher and higher. If it goes into a bay, it's focused and it raises it even higher. Hundreds of feet, literally, up the hillside sometimes. In Indonesia that happened, in Krakatoa. It also has happened in Alaska during tsunamis. There was a giant earthquake in 1960 in Alaska when it was really not very highly populous. It still isn't. That caused a lot of deaths along the coast because of this focusing effect. Between two islands is a particularly bad spot for a tsunami because all that water is trying to get through a narrow spot and it piles up. And the same thing happens as it comes onto shore. The period of one of these waves is, as I said, 15 to 60 minutes. There may be more than one. So once the wave is passed, don't think you're out of the woods. The next wave, the third wave may be the biggest one, or the second, maybe the first. You don't know. So you need to keep that in your mind as you're trying to collect your thoughts after the first wave arrives. So if you think of a pancake of water going usually by the time it reaches shore only around 40 miles an hour, well, that's a lot. That's faster than any river you've probably ever seen. It's low height in the open ocean, but in shallow water, often very high. And in the case of the Fukushima, where the nuclear plants are, it came in at 40 feet. They had a seawall to protect from storm waves, primarily typhoon waves, that was around 18 feet tall. But of course, the wave, first of all, went over it. And even if it hadn't, it would go around it because it just keeps coming and keeps coming and keeps coming. And that was where the damage to the nuclear plant occurred. No one conceived, for whatever reason, that a wave that big could come in. They travel long distances without a great deal of loss of energy. This is a wave height diagram. It was used on the website. The earthquake is up there in the top left corner in Japan, just offshore, about 40 miles offshore from Japan. The wave heights that were predicted from that form this amazingly complicated pattern. As they hit islands like Hawaii, here in the middle, you end up with higher waves as it comes into shallower water. And again, actually people were washed away, although rescued, in the area of Northern California, Southern Oregon, because the wave reached that distance. The power of the wave falls off with the wavelength, 1 over the wavelength. So the bigger the wavelength, the farther it goes without losing energy. So it can go all the way across an ocean, 8,000 miles, and still be very significant. So when there's a warning, you want to take advantage of that. Now, get to my next little diagram here, which shows Sri Lanka from 2004. One of the other things is you might feel that if you're on the backside of an island, you're going to have some protection. But because of the wavelength of these waves, you don't have that protection. These waves rise, in this case, several meters, as much as 2, 4, 6, about 8 meters, which is 24 feet. Around on the back side of Sri Lanka, when it came from the east side and passed through, it came all the way around, and only Colombo, which is fortunately on the eastern side, which is the most populous place, was protected to some extent by the island. So very complex patterns. Harbors, there can be resonances, and the wave will go back and forth in a harbor and wash boats loose and knock people off docks and things like that. Travel times are well known, and they, for long distances, are many hours. These are hours from an Alaskan earthquake at the top, showing it takes it to reach Hawaii 6.5 hours. So there is a warning time if you're a long ways away. If you're close, these waves are coming at about 400 miles an hour. So you get very little warning, a minute or two at most. So if you feel that earthquake, you want to move fast to high ground. Now, I'm going to just leave that for a moment. How to survive a tsunami is the next little discussion here. Most people, or many people, will survive the earthquake. It will be less severe. The tsunami will be more severe almost always. Heed natural warnings. Earthquakes, a rapid fall or rise of the ocean. If the ocean starts to pull away from the shore, run the other way. Run the other direction. Don't stop to look at all the fish flopping on the shore, on the water there. People do. People run down to take pictures. This is not the wise thing to do. If there's an official warning, just because the last 3 turned out to be 6-inch waves, follow the official warning, go to high ground. Expect more than one wave, head for high ground and stay there. Abandon your belongings. They won't matter. Your life matters. Don't count on roads. If you're near an earthquake, the road may have a 1-foot drop in it that you can't get your car over. There may be a sudden jump in the road if you're near an earthquake. Only if you're trapped and unable to reach high ground, go to the upper floor of a building. If you don't have that, climb a strong tree. If you're trapped on low ground. If you end up in the water, climb onto something. An individual was found 9 miles at sea on the roof of his house after the tsunami in Japan and rescued several days after the tsunami. He was washed 9 miles out and was rescued because he was on something that protected him from everything else floating around in the wave. Expect lots of debris. Expect that the shoreline may be different. It may be, the land may have dropped 3 feet, so the shore may not be where it used to be. And then expect company and help out your neighbors, because that's the key to surviving any of these, is working together. The nuclear plant disaster probably is not going to be the major cause of loss of life here. Much as everyone worries about nuclear power and radiation and the dangers of it, despite the disastrous results of inadequate planning for a large wave, which should have been expected, because it can be anywhere in the Pacific, the picture of what happened to the nuclear reactor is this. The fuel is over in the left side there. Those red rods are where the fuel is, which is a very, very hot place. When the control rods are removed, the nuclear reaction that goes on generates very high temperatures, on the order of 2,000 degrees. That's used to generate steam to drive a generator, which then generates electricity. The reactor part itself, that light bulb shaped thing over here, is a heavy steel lining, and that's designed to withstand almost anything. The one thing it can't withstand is if that nuclear reaction is going full steam and drops bits of molten stuff onto the steel and can actually melt through it. There's some question that this may have happened at one of the reactors in Japan at this point. No one can get really close enough to know for sure. So some of the guesses and maybe this and maybe that you hear from the power company are understandable because there's no one volunteering to go in and take a close look. They fly over, they use whatever they can get, robots to get cameras in there, but they can't see everything. The reason the reactor failed is not, interestingly, because that shell of the reactor failed. The reason it failed was the power went out. It was a power failure. Now that seems ironic, but the power failure actually caused the coolant that keeps the thing from going crazy to stop. The generators were knocked out by the tsunami because they were on the ground floor, which is a mistake that will be fixed in power plants in the future, we would hope. And without cooling, that reaction begins to go. Even though the neutrons are stopped because the control rods are dropped, yes, it's turned off, but it stays hot for a matter of a couple of weeks. And that heat is sufficient to melt its way right down into the concrete down below. It doesn't keep going. Eventually it stops. It's a blob of highly radioactive stuff. It happened at 3 Mile Island in Pennsylvania. No known fatalities from cancer, no measurable increase in cancer anywhere in Pennsylvania from that. It happened at Chernobyl. There was an increase in thyroid cancer because children continued to drink their milk and think everything was fine because, frankly, the government didn't tell anybody what was going on. That was known to Europe only when radioactive material from it reached Sweden and power plant workers going to work set off the alarm from their boots. That was when we found out. Hundreds of miles away, the contamination set off alarms at a power plant by workers going to work, not coming out. So the governmental system is fairly important here. And the reporting is the best they can do. I'm quite sympathetic. It's very difficult to know what's going on, and they make their measurements and try and guess. But you can't really go and take a peek because it's too dangerous, and it will probably continue to be here for hundreds of years, if not longer. It's going to be very difficult to remediate this. These power plants are dead. They're not going to come back online. They put seawater in there, which is corrosive, to try and cool it off. That right away meant that they'd given up on ever trying to save these plants. Why are we so afraid of radiation? This is my last point, and I'm going to, second last point. You typically are exposed to 2 millisieverts of radiation a year, maybe 3, maybe 6. That would be typical for a citizen in the U.S. around here. If you live on the Redding Prong in Pennsylvania, a little higher than that because there's radon in the soil and that radiates you. If you are an airline crew and you regularly fly over the pole from New York to Tokyo, you were exposed to about 9 millisieverts per year, 4 times the average, just because you're higher in the air and you're over the North Pole where there are a lot of incoming radiation from the sun. If you are an industry employee, you're limited to 20 millisieverts per year, which is more conservative. It was about 50 when I worked for New England Nuclear here in Boston many years ago, about 35 years ago now. The routine limit used to be about 50 millisieverts per year. There are places where the natural radiation level is that high. 100 millisieverts per year is the lowest level at which any cancer, additional cancers can be detected. So that's significantly higher than, 50 times higher than what you would ordinarily be exposed to. You can't escape it all. There's potassium in your body. It's radioactive. You would die without the potassium. Some of it's radioactive, so one of the isotopes. So there is always some radiation. So your fear of tiny levels of radiation is a little misplaced because it surrounds you all the time. It's in the concrete in the walls. If you live in a concrete building, it's a little higher than if you live in a wooden building. These are all factors. The highest reached at the Japanese nuclear site on the 15th of March was about 400 millisieverts per hour, which is why no one is able to go in and take a close look. If you receive 1,000 millisieverts in a single dose, you get radiation sickness. You don't die automatically. If you receive 5,000 millisieverts in a short period of time, about half of those people will die from radiation sickness. So this is the kinds of levels that you're talking about in Hiroshima and Nagasaki after a nuclear bomb went off. So what do? Your risk perception is very important. And people are afraid of radiation for 12 of these 14 reasons. They aren't all necessarily the right reasons. You're much more likely to die in an automobile accident, quite frankly. But you have a lot of factors in your favor in an automobile that give you more feeling of safety, despite the fact that you're not. Trust versus lack of trust. Do you trust the government, industry, or interest groups? I.e., the government of Japan, the power company, or Greenpeace. You got to listen to who's telling you things. In anything nuclear especially, there's big money involved on all sides. Imposed versus voluntary. Driving with our cell phone is safer than if you're driving with your cell phone and I see you doing it, and it makes me unhappy because you're all over the road. All right? Natural versus human-made. Sun radiation, standing outside, gives you a lot of radiation. Nuclear radiation, you can control that, so you don't want that. That's scary. Sun's worse. Don't stand outside. Plane crashes, much more scary than heart disease, just because it's catastrophic. Cancer, a dread of having cancer because you've known people that died of it. Everybody dies. I mean, everybody dies. I'm an optimist. The optimist fell 10 stories. At each window bar, he called out to his friends inside, all right so far. So, that's the way I look at a lot of these. Uncertainty, new technologies, hard to understand. Nuclear, chemical, those are the scary things. When you go to an ES meeting, those are the ones everybody talks about, Is it on the news every day? Do you keep being reminded over and over and over again, oh, there's radiation, and then you turn it on and there's more radiation. It's the same radiation. It's still scary, but it's there. A known victim, if you know somebody who died of it. If kids are involved, and kids are involved because the main hazard coming out of this plant is iodine-131, concentrates in children's thyroids, causes cancer. 25 known deaths from thyroid cancer at Chernobyl, thousands of cases, operable cancer, easy to cure, easy to look for. Does it affect me? Everybody wants zero risk. There is no zero risk. Life is not risk-free. Risk versus benefit. Vaccines. How many people are afraid of vaccines? What's the benefit? What's the risk? Is there a risk? Control versus no control. And at that point, I'm going to stop. I ran way over, and I apologize, but let's see if we can get to questions.
We'd love to take your comments, questions, and if you want to come up to the mic here so that you're recorded and heard, we would appreciate it. Sandy.
There's one question that was tweeted. Is there any relation possibly between climate change and geologic activity?
Well, climate change is a long-term thing. I just finished teaching a class on climate change an hour and a half ago. Not directly is, I think, the simplest answer. It's just one more thing to worry about in the long term. Climate change is changing a lot of things biologically. You can't point at one organism dying out or one storm as some evidence of climate change. Climate is a long-term thing. And understanding that it's changed in the past slowly and that it's changing now very rapidly, I think, is the take-home message on climate change. That what we do is now affecting the climate, and we need to be concerned about that. But in terms of the earthquakes, they're really driven by the internal heat of the earth. And that's what's making it all move, and that's why we're getting the earthquakes and the tsunamis. Yeah?
Any other questions or comments? Or stories you've heard from people in Japan or elsewhere who've experienced this kind of, yeah.
Hi, I'm Carolyn. The Sierra Club has recently issued a statement saying that they're no longer going to collaborate on any bill that requires a significant nuclear commitment from the United States. Do you think that's a valid response to what's going on in Japan, or are conditions different enough in the U.S. that it regarded it as more independent of Japan?
That's a good question. Do you have a thought on that?
I have my opinion. If you ask the question why there's so much nuclear power in Japan and France and other places, and not everywhere, the answer is economic. Japan has no coal, no oil. If they import all their power needs, it's very expensive, the balance of payments is terrible, and their economy will look like ours. Hugely out of balance. Nuclear power is one way to theoretically get less expensive power. But you have to ask the question, if they require federal government to back them up on liability, how cheap really is it? What are the real costs? And of course, coal has real costs as well. Miners die, air pollution, people die of air pollution. Oil the same, it's going to affect the climate. These are all trade-offs that someone has to make wise decisions about. I would suggest that if you had a take-home political message, it is, tell your congressman to make sure that people who inspect nuclear power plants do the job right, make a report, and that it doesn't simply move up a line of bureaucrats and stop somewhere because it's going to cost somebody a lot of money to fix when they could wait 6 months for a shutdown and then fix it. That's a concern. The NRC doesn't have the greatest record of finding problems and stopping a reactor to fix it. The nuclear industry actually is pretty good because they are in, the NRC gets down on them big time, but vice versa doesn't happen. The NRC hears from Congress, and Congress tells them, that's going to cost a lot of jobs in my district if we shut that down, because then we can't run the XYZ plant.
NRC stands for Nuclear Regulatory
Right,
Commission
right.
in the United States. Good question. Yes.
Hi, I'm Barbara. Thank you for coming to talk to us about this today. I was wondering, do you think, in your opinion, do you think the media has been like kind of accurately portraying the situation in regards to the nuclear power plant explosions in Japan, or do you think they're kind of like hyping it up a little bit more than they should have been?
You want to get to the science of that, since I can't talk about the media and the science, and I'll talk about other aspects?
As I said before, I think the tsunami is a much bigger disaster, and people being exposed to cold and not being able to get electricity, food, fuel, and clean water because no one will drive up there with a truck. That's a concern. The people who do drive that and who go in there who are trying to take care of that plant, they have my sympathy because they have a tough job. But I think the tsunami overall probably is going to be more damaging than the nuclear. The problem with the nuclear is that some of that stuff is going to be on the soil for years. And it may mean that there'll be an area that'll be evacuated. It's certainly true around Chernobyl, where a town has been deserted. Pripyat has been essentially completely evacuated, and no one lives there anymore. It had thousands of people in it. They were within view of the Chernobyl plant, and the soil was contaminated over wide areas. And it's cesium, which is a long-lived isotope. The iodine you hear about in the ocean is a less concern because it's gone in a couple of weeks. The cesium lasts for decades. So that's the thing to watch for if you're concerned with the soil and the water pollution going on at these plants.
I've been following some of the media coverage in Japan by the Japanese media. And just this morning I was reading about some critical comments or analyses of the way that some media are portraying, for example, the workers in the Fukushima reactor area. So on the one hand, many of them are being turned into or transformed into these poster people for heroism and self-sacrifice. But this one article I read went deeper and found that Tokyo Shimbun had actually done an expose or an investigative report that the Japanese government and TEPCO, the electrical company, are having a hard time recruiting people to come work. So they need to offer monetary incentive, and that there are many who are above age 50 who are more susceptible to take this because they feel more insecure about their job. Japanese retirement age is it's set much lower than in the US. So for a 50-year-old to be worrying about being out of a job, et cetera, is not unrealistic. So there are questions about equity. One article I read said, are they heroes or are they victims? So that kind of analysis is not being regularly addressed. And I think right now people are so worried about the crisis aspect of it, but once the crisis aspect of it gets under control, I think we're going to see a lot of political, social fallout and blame gaming and finger pointing and all this. It's already happening in Japan, and I think it'll get worse.
Something similar here, actually. When I worked at New England Nuclear 35 years ago, everyone who dealt with the highest levels of radioactive materials there were over 50. They felt men beyond childbearing age were probably the safest. No women, no young people worked with the radioactive materials, because it's a cumulative effect and often not expressed for 20 years. And if you're 70, 20 years, well, you're going to die then anyway, probably.
We're going to learn about professors' philosophies of life, you know. One other thing that I think personally I have found disturbing in the American media is this recent trend to emphasize the potential dangers of radiation in the United States. I mean, in my view, frankly, this pales as a concern to what is going on in Japan, but also if you're going to cover other countries and communities affected, the East Asia region is much more in danger of being affected, both environmentally but also economically. And I think that aspect is completely missing in at least American news coverage. One question I did have for you, and I was able to vent all my frustrations because I was so confused and had so many questions that I couldn't answer myself in the immediate aftermath. And unfortunately, our college's spring break got between us and Japan, so I wish we could have had this sooner. But when I did email Professor Besancon with some questions that I personally was curious about, one of them was, what are the environmental, geological effects on the East Asia region? And also, I was really curious, what actually stops a tsunami? Is it that there's enough debris and enough solid matter in the way that it stops, or?
It just washes back. It's like any wave. It goes on for a while and it backs up for a while. In Hawaii, I was watching it at midnight as it came through Hawaii on a live feed from a camera, and you simply watch the water creeping up in the harbor. And they said, oh, it's reaching all the way to the tree line. It's into the trees. And then it slowly crept back down because it was relatively low magnitude at that particular place in Hawaii. So it's a wave, and it goes by. And once it's gone by, it keeps going, but it's gone past. And then there may be another wave or not. And eventually they stop. And typically 3.
And the impact on the region from your standpoint?
Everywhere. Anything along the coast is, everyone will have to rethink about where they live and where they build facilities of all sorts. In Hilo, Hawaii, they've moved downtown 3 blocks back from the shore because they've had repeated problems with tsunamis, both from South America and Alaska, and 40 feet high, and many deaths. And they've actually built a park. And they've also built some hotels right on the shore, but the hotels start at the 2nd floor, and the first floors are all breakaway. And the wave will go right under, in theory. I stayed in a hotel there, so I guess I believed them. It'll wash the wall away, but it won't wash the support columns away. The wave will go under, and it'll go back, and the hotel will survive. Now, whether it'll survive having a car hit one of those pillars, I don't know. But, yeah, so it's going to involve a lot of thinking about infrastructure. In California, where there are earthquakes, and in the Northwest, where there are tsunamis known, and in Alaska, places like that, they've already begun to deal with this kind of thing. We can guess from the size of the deposits that are left, what kind of damage is conceivable. Clearly, this is a conceivable event, and should have been planned for, and that was a mistake. But it's not it's a mistake because it's a lot of money to build everything higher. They have to be near a water source to have a nuclear power plant.
What I also looks good.
The ocean looks good, but it has its dangers.
What I also found ironic is that at first glance, when the news came, I thought to myself, why did they build these reactors on the coast where the tsunamis, obviously, that's where they start. But looking into this a little more, and as more information came out, I learned that the government and the industries decided to place them on the coast of that region, particularly because they were considered lower risk than some of the heavier earthquake zone risks in Japan. And so it's quite ironic that the area that was considered lower risk has ended up becoming such high risk an area. And also something else that's not raised so much in the American media is the fact that the reactors were designed by General Electric. So there are questions about design, which rarely gets mentioned. And then, of course, the big question, which a lot of people have asked, is why are 30-plus-year-old reactors still functioning and not being updated, right? And that's a question for both the government and the industry in Japan. And so many have been very upset about that. And we have old reactors in the US, we have old reactors in Europe, so this is a question that's affecting a lot of people. What's also interesting is how immediately the Europeans pulled back from any discussion, further planning about nuclear energy. The Chinese at first said, we're going to keep going, you know, we need energy. And then the Chinese began to pull back a little bit within a week or two. So how this nuclear situation in Japan affects nuclear energy development worldwide, I think, is a very interesting question. We'll take one last question. Okay.
Hi, I'm Stephanie. I'm from California, and I've been learning a lot about the nuclear reactors in California. You said that it was conceivable that this could happen in Japan, and those who are studying the plants now in California are saying that they should be able to withstand earthquakes and tsunamis. But obviously they had said that in Japan too, and well, it didn't happen, so.
Right. The question for anything that's potentially damageable in a tsunami is, if you look at this area of Japan, there's a long coastal plain that's really quite flat. And that's where the waves will move 2 or 3 or more miles inland or up rivers. And the need for water is important. In California, you have an advantage, however, in that most of the coastline is much steeper. So you can build a power plant that's above the level where it's susceptible to a tsunami, and you can build them sturdy enough to survive an earthquake. This plant survived the earthquake. It just didn't survive. Its backup power generators did not survive the tsunami. The batteries lasted 8 hours. They couldn't get in to get the pumps going again, and that's where the disaster started. So it was really the water. You can build a plant that will withstand an earthquake like this, probably. They claim they can. I don't know. And this one did, but of course the earthquake was 40 miles away. So, yeah,
Thank you.
That's a good question. Thank you.
Thanks to everybody who's come and who stayed. And for those of you who are still here, we have another East Asian Studies event coming up on Monday, 4 to 6. A New York Times correspondent who covers Korea will talk about the crisis in North Korea over nuclear weapons development. And he's a Pulitzer Prize-winning journalist, and he will also talk about careers in journalism and the media. So I encourage you and your friends and colleagues to come. So thank you for coming.
Mm-hmm.